Our next section, section 1.2, Borders Method, investigates how we can use all the information that's available to us, should we have preference rankings, in determining who the winner of an election is. So this method tries to make better use of all the available information. If we look at plurality and runoff elections, there's a lot of information if we have full preference rankings that's available to us, but that information is neglected by these two methods. And so this method attributed to Border is a scoring system, a way of assigning what we can call victory points, for lack of a better term. And the candidate with the largest number of victory points is the one who then wins the election. And the points are allocated in such a way that it's based on the preference ranking of specific candidates. So let's talk through this method and the implementation thereof in a little bit more detail. Let's assume that there are C different candidates. So the letter C here is a placeholder for the number of candidates in the election. We then assume that each voter is able to provide us with a list where they have ranked the candidates from most favorite to least favorite. And as mentioned in our previous lecture, in reality, it may be that people do not have a preference of some candidates. Like they have a clear first choice, a clear second choice, and they don't really care about the remaining three candidates. What we're going to assume here is that they then arbitrarily or randomly assign preference rankings to those candidates. So each voter is able to give us a list of rankings where they rank every single candidate in the election. We then assign points based on those rankings. So if we take a specific voter's rankings, then the candidate they ranked lowest is only going to receive 1 point. The candidate they ranked second lowest is going to receive 2 points. And you'll work your way up until you get to the candidate they ranked first, the top candidate, who will receive C points. In other words, that candidate will receive as many points as there are candidates in the election. So we assign points for each voter, and then we take the candidates and we sum their points. And when we total or sum these points for each candidate, the result is called a border count. And the candidate with the highest border count is the one who wins the election. So this is just a way of trying to take the full preference ranking, giving a lot of weight to candidates that rank highly, like your top choices, and only give a little bit of weight to candidates you rank much lower on your preference list. And so we try and use all of that information. Now, as you can imagine, and in fact, as you'll see in an example in a minute, it's a tedious process to calculate these border counts. And especially if you are running a large election with a large number of voters, it can be a very tedious process. In fact, in those instances, you may want to use some technological tool. Something like a spreadsheet in Excel can make life a whole lot easier there for calculating the border counts. But even so, you may want a way of checking your work. So one option, of course, is just to redo the calculation a second time independently and see if you get the same result. But there is a quicker way to at least do a partial check. So notation-wise again, the letter C represents the number of choices or the number of candidates in the election. and the letter V denotes the number of voters in the election. So if we take each voter's points and we add them up, 1 point goes to their lowest ranked choice, 2 points goes to the second lowest ranked choice, all the way up to the highest or top choice who gets C points. So if we add up all the points they have to assign, so 1 plus 2 plus 3, all the way up to however many candidates or choices there are, then it is a mathematical fact that if you add up all the numbers, all the integers from 1 through C, that sum is equal to C times C plus 1 divided by 2. So we know for a specific voter exactly what the sum of their points will be. And we know how many voters there are. So the number of voters times the sum of all the points tells us, if we go and sum up all the different border counts, that should equal V times C plus 1 over 2. And all this is, V is just the number of voters, and we multiply that by the sum of an individual voter's points. And that's the same for all voters. That's why we can just take that C times C plus 1 over 2, multiply that by V for all the voters. So after you've calculated your border counts, you can add them up and you can run a check to see, do they add up to this same total? Now, sometimes in an election, the actual number of candidates can be overwhelming. Like initially when we think of elections, we think of getting a ballot. Maybe there are 2 choices, maybe there are 5 choices. It doesn't seem all that burdensome to ask someone to rank 5 choices. But if you go and look, for example, at some of the primary elections that happen both in the Democratic and Republican parties, sorry if I'm leaving out smaller political parties, but at least with these 2 parties, you will sometimes see in primary elections before a general election, they will have a really large number of candidates. In fact, just think back to a few months ago, people were trying to figure out who would be the Democratic nominee for president of the United States in the 2020 election. And we know that there were close to 20 candidates running. Now, if you had asked someone to rank 20 candidates in their order of preference, they probably wouldn't be able to do that because they wouldn't know enough about all of them to rank all of them. So a modified system or a variation on the border method is to ask people to only rank their top choices. In that primary situation, we could have said, well, we know there are 20 candidates. All we ask is that you rank your top 3 choices. And in fact, this doesn't just have to happen in a political election. If you're a football fan, you probably know about the Heisman Award. It goes to a college football player every year. And if the border method were used here, then the people who vote on who the Heisman winner is going to be would have to create a complete ranking of every college-aged football player in the US. Like there are thousands of them. Nobody's going to be able to rank 1,000 people. So what the Heisman Award does is the voters get to rank their top 3 picks. Their top pick gets 3 points, their second pick gets 2 points, their lowest pick gets 1 point, and then the border count gets calculated in the same way, even though not all players have been ranked. And in fact, there are sometimes variations of borders method. Like, you could make an argument that allocating, points equal to the number of candidates being ranked is somewhat arbitrary. Why are we assigning 3 points, 2 points, and 1 point? We could do it differently. And this gets used in the real world as well. For example, the NBA, when that association votes on their most valued player in a season, people again don't rank all the players, they rank their top 5 players, but rather than their top pick here getting 5 points, the top pick here receives 10 points. They want people's top pick to get a lot more weight in the election. The next pick gets 7 points, and it keeps on decreasing, 5 points, 3 points, and then 1 point. So there are variations that assign points in a different way, and there are sometimes practical reasons for doing that. And we will definitely look at a couple of examples that play out in this way. But let's start with an example that looks at a basic implementation of Borders method. So let's say we have a committee consisting of 5 people. This committee has to select a new chair. There are 3 candidates running for chair: Coleman, Horowitz, and Taylor. And they have decided to use border method. So each of the committee members creates a preference ranking. So what you'll see again in this table is the first column here corresponds to Coleman being ranked first, Horowitz being ranked second, Taylor being ranked third, and there was one person who came up with this preference ranking. Next, we have a preference ranking with Horowitz first, Coleman second, Taylor third. And there were 2 voters who submitted this preference ranking. So if we add up the number of votes cast, we see 5 votes cast, which makes sense, 5-member committee. Now we want to calculate the border count for each candidate. So we do this in a candidate-specific way. So let's start with Coleman. And because there are 3 candidates, Coleman could be ranked first, second, or third. So let's take a look at Coleman and say, how many times was Coleman ranked first? That happened once. How many times was Coleman ranked second? Well, there are 2 different preference rankings with Coleman second, but that corresponds to 3 voters. So 3 times Coleman got ranked second. And finally, Coleman being ranked third, that happened once. Now, points allocation, 3 points when ranked first, 2 points when ranked second, 1 point when ranked last. So we do these multiplications and we add the numbers after multiplying together. In this case, 3 plus 6 plus 1 is 10. That is the border count for Coleman. Coleman has a border count of 10. Now, let's do the same thing for Horowitz. How many times was Horowitz ranked first? Let me just clear things up a little bit here, and let's focus on Horowitz. So Horowitz was ranked first 2 times. How many times was Horowitz ranked second? Well, that happens in 2 different preference rankings, each one corresponding to 1 voter. So 2 times that Horowitz was ranked second, and 1 time that Horowitz was ranked third. So when Horowitz is ranked first, 3 points are allocated for each first ranking, 2 points for each second ranking, 1 point for each last place ranking. So we do the multiplication, add those together, and in this case, we get a border count of 11. So Horowitz has a higher border count than Coleman. And what about Taylor? Well, let's check that one too. So let's look at Taylor. Could be ranked first, second, or third. Taylor gets ranked first by 2 voters. Taylor never gets ranked second. And finally, Taylor gets ranked third by 3 voters. So twice Taylor gets 3 points, 0 times Taylor gets 2 points, and 3 times Taylor gets 1 point. So Taylor has a border count of 9. And so this means Coleman is the election winner if we use the border count method. Now remember I said there's a way to check your work. In this case, we know there are 3 candidates and there are 5 voters. So V times C plus 1 over 2, that's the sum of all the border counts. In this case, that would be 5 times 3 times 4 divided by 2. So all the border counts have to add up to, if you go and do that calculation, 5 times 3 is 15, times 4 gives us 60, divided by 2 is 30. So what are our 3 border counts here? 10 plus 11 plus 9. Our border counts add up to 30. Now, this is not a guarantee that your calculation is perfectly correct, but it is a way of checking, because if those 2 numbers are not the same, then you definitely know that something went wrong along the way with calculating your border count. So it's always worthwhile to at least do that as a quick check so that you know whether there is a good reason for you to go back and rework your problem. And this is the end of our section 1.2 lecture, and we will definitely do a good few example problems of this in our live Zoom session on Tuesday, June 2nd.